In this video, we're going to be talking about relations and functions. And I just want to real quick remind you of what a relation is. A relation is simply a set of ordered pairs. And what we mean by ordered pairs is like your XY plot points like 1, 3, 2, 4, 5, 9, a set of ordered pairs. And the reason we call this a relation, because an ordered pair actually shows a relationship. The first number in a set of ordered pairs, the first number is your x's, the second number your y's. And when you have a point, it actually shows you how x and y are related. It's the relationship between x and y. So a relation is an entire set of these. So an example would be like 1, 5, comma, 2, 8, comma, 3, 13. So it shows you, okay, in this set, what if x were 1? What if x were 2? It shows you how it's related to y, and that's the reason we call it a relation. We can represent relations in different ways. We can represent them with tables, to where your x's are on one side and your y's are on the other. And again, that would show you how your x is related to your y. This is just another way of writing a set of points. We could also represent a relation as a mapping, to where one circle represents the x's and the other oval, or excuse me, represents the y's. And a mapping again shows, okay, which x's are related to which y's. Like in this one, 5 is related to 3. -2 is also related to 3. Or I want you to start thinking again of x's and y's as inputs and outputs. If I were to put 5 into this relation, I would get 3 out. If I were to put in a -2, I'd get 3, and so on and so forth. We can also represent relations with graphs. Let me move my screen again. And you can see here on this graph, I've plotted these 4 points to where the horizontal axis is your x, the vertical axis is your y. So this point right here represents the same thing that one of these points would represent. It's an xy relationship. This point at 2, 2, when x is 2, y is 2. This point at, I think that is 5, 3, when x is 5, y is 3. And finally, we can represent a relation as an equation. And the reason that would be a relation is we could take any x value and plug it in. Well, what about when x is 2? We could take that value and plug it in, and we'd find out that y is, let's say, 2 squared is 4, -12 plus 7 would be -5. And we could do that for a whole set of ordered pairs. So that's all the different ways that we can represent relations. Now let's talk about, when you're dealing with a relation, what do we mean by domain and range? The domain of a relation is the set of all x's. Or I'm going to call them the inputs. Those are the values that you're putting into your relation. The range is going to be the set of all y's, and that would be your outputs. When you put in certain x's, what y values are you getting out? That would be your range. Okay, so now in the next few problems, let's identify our domain, let's identify our range, and remember that domain and range are sets. So therefore, we're going to put them in set notation. We're going to have our braces here. Our domain is the set of all inputs, or the set of all x values, and I like to put these in order. So let's do -5, -1, 3, and 7 are all of our inputs, or all of our x values. Our range is a set of all y's, and putting those in order gives me -1. You have 2 different -1s. However, when you're dealing with a set, you don't have to list those twice. So -1, 0, and 4 are the set of my y values. On number 2, my domain, the x values of the points. If you're given points, here's what I like to do. My x values would be this value, this value, this value, and this value. Because that's where my points are located at. Here, my x value is 1, 2, 3, so -3. Here, my x value is -1. Here, my x value is +1, and here, my x value is 2. Now, you could take, if you wanted to, and actually find those points, but you really don't have to. The set of y's would be this y value, because we have points there and there. We have a point here, and a point here. And that also puts your y values in order as well. So I have -1, 2, 3. Here, x is -4, or y is -4. So my y values are -4, -3. Here, my y value is 0, 2, and 5. So there's all my different y values. Okay, number 3, the domain, the set of all x values. This one's actually given to you since it's a mapping. Here's all your x values. So your domain is going to be -2, -1, 0, 1, and 2. Which is very easy to identify domain and range when you're dealing with a mapping. Your range is simply 0, 1, and 4. And that's it. It's a little bit more difficult finding domain and range when you're dealing with this type of graph. Okay, here's how I like to do. Think about domain as this. Where is your graph located? Do you have any graph located here? Is there any graph located here? What about here, here, or here? Now, when I'm dealing with domain here, what you've got to be really careful of, it doesn't look like there's any graph over here, but this graph continues on, and it's going to taper out, taper out, taper out. It's not slanting quite that much, but it's slanting out ever so much, and eventually there is going to be graph over here. So you ask yourself with domain is, where is x located? How far left and how far right does my graph go? In set notation, your domain is you have graph everywhere. So therefore your domain is going to be all real numbers. Okay, so I'm just going to put, well, I don't like the R because you got range as R. So for your domain, we're going to put all reals. Okay, your range. Your range is which y values are on your graph. Start drawing some lines. Is there any graph down here? And yes, there is, because this continues on. Is there graph here, here, and here? Yes, there is. My graph stops here. So my graph runs from -infinity up to this point. So it says, I know it says to write it in set notation. I actually want to write it in both notations. My range runs from -infinity all the way up to this y value. Now we got to figure out what that y value is. So just count 1, 2, 3, 4, 5, 6. That's a y value of 6. So -infinity all the way up to 6. So in set notation, I'm not going to write the entire set. I'm just going to say that my y values are always less than or equal to 6. And you could write that as a set of all y's such that y is less than or equal to 6. That would be fine as well. Number 5, your domain. Left or right, draw you a vertical line and start moving it and ask, where does my graph start? My graph starts here when I'm dealing with my x's. Where is here? That's going to be an x value of -3. And notice, how far does your graph go? Well, it goes forever because you got the arrow. You never have an ending point. So your domain here in interval notation would be all values from, it starts at -3, and notice that -3 is included because it's a closed circle, all values from -3 forever. Or in inequality notation, you could say that would be x is all values, and the reason I use x because it's domain, that's a set of all x's. All values greater than or equal to -3 would be your domain. Now let's erase that and talk about your range. Where does my y value start? What's the lowest y value on my graph? There's no graph down here, no graph here. My graph starts at this y value. Now what is that y value? 1, 2, 3, y is -4 there. Now how high does my graph go? And I know it doesn't look like there's graph up here, but it slants and it gets higher and higher and higher forever, which means there is going to be eventually graphs somewhere up here. So my y values start at -4, I always start with the lowest number, and it goes up forever. So that means my y values are always greater than or equal to -4. Okay, number 6, domain and range. Again, take a vertical line to try to see where your graph starts and start moving it. Since this line says it continues, then it has no beginning point. So your domain starts at -infinity, and it goes up to. Okay, you've got a missing value. It looks like it stops here. Okay, and there's no value at, this is 1, 2, 3. So it goes from -infinity up to 3, and then it stops. However, then it starts back. On the other side of 3, notice that this gets closer and closer and closer to 3. This is, we'll again review later on, it's called an asymptote line at 3. Your graph has no value at 3. However, on the left side of 3, it approaches it. On the right side of 3, it also approaches 3, but there's no value on your graph at 3. So it goes from negative infinity to 3, stops, then it starts back on the other side of 3, and then it continues on forever to positive infinity. And we could actually just write that as from negative infinity to 3 and then 3 to infinity. We could just say that, you know what, x is everything, but it's not equal to 3. X can be anything except for 3. Now let's do the same thing for your y values. Let's start down here at the bottom. Always start at the bottom and work your way up. Do you have graph here? Yes. Where does your graph stop? You also have what's called an asymptote line here. So your graph goes from negative infinity up to this line, and this line is located at a y value of 0. So it goes from negative infinity to 0, and it stops. It jumps the asymptote line, and then it starts back on the other side, and it goes from 0 to positive infinity, which pretty much says you have graph everywhere except for 0. So y is equal to anything except for 0. So if you only have one excluded value from your domain and range, it is perfectly fine just to say x can be anything or y can be anything except for. X does not equal or y does not equal that single point. Okay, on number 7, you actually have what we call a sine curve, which we'll do later on in the year. It says to give the domain and range of each in interval notation. And again, you can think of it both ways. Now, here's the issue here. This thing does not continue up. Okay, with the sine curve, and you kind of need a little bit of background, this thing's going to continue at the same pattern. It's going to go up, down, up, down. It's your domain here. This thing goes forever. Okay, there's absolutely no breaks. So therefore, how far over does it start? Well, it goes forever. When does it stop? Well, it goes forever in that direction. So where is your graph located with your domain? It's anywhere from negative to positive infinity. There's no breaks in it, so it goes forever in both directions. Now, what about your range? Your graph stays between here and here. It never goes below this line, and it never goes above this line. Now, what are the lines? Let's see, 1, 2, 3, 4, 5. This is negative 5, and this is positive 5. So your graph is always between negative 5 and positive 5 on the y-axis. Since the points here at positive 5 and negative 5 are actually part of the graph, we do include them. Okay, number 8, domain. My graph looks like it goes left and right forever. However, there is a missing value in it. There's a hole. So that means that my domain can be anything except for this one value right here. And when we're talking about domain, we're saying what is this x value that's missing? And we're just going to say x is not equal to negative 1. That's one way of doing it. But they want it in interval notation. So here's what you're going to do. That means that x is equal to any value from negative infinity up to that negative 1. But negative 1 is not included. Or any value from negative 1 to positive infinity, but that negative 1 is not included. So in interval notation, that's what it would look like. Your range is missing this y value. So you have graph everywhere except for here, and then your graph starts back up here. So that is any value except for negative 1, 2, 3. So your y value is not equal to negative 3, which again, to write that in interval notation would be all values from negative infinity up to that negative 3. And all values from negative 3 to infinity, just not including the negative 3. Number 9, domain. There's no graph over here. Your whole graph is from negative infinity to here. So how can we write that? That'd be all values from negative infinity up to 0. Now, is 0 included? Well, since this part is part of your graph, yes, it is. Your range, is their graph down here? Yes, it goes down forever. Is their graph up here? Yes. So your range would be all values from negative infinity up to positive infinity. There's no breaks in the range. Number 10, looks like you've got some sort of exponential type graph here. Now this thing, we're going to assume that it continues tapering over. So it goes left forever, and it eventually is going right forever. It's going more slowly to the right. So my domain is going to be any value but my range will not be. Notice that it looks like, again, you have an asymptote line. It looks like it levels out right here. Anytime that you have a graph leveling out, it's going to level out, but it's never going to cross this line. So it's never going to touch it. So let's see, what is this line? Negative 1, 2, 3, 4, 5. So it's going to go down to negative 5 and it levels out. So my graph is from negative 5 and above. So negative 5 to infinity because it goes up forever. Now, again, the question is, will I include negative 5? And the answer is no, because it doesn't get there. It comes down and it levels out at negative 5, but it never touches it. It never crosses it. Number 11, again, I have a break in my domain here. You see that I have, again, what's called an asymptote line there, but it looks like my graph goes left and right forever other than that. So I'm going from everywhere from negative infinity up to that x value, which is negative 1, not including, and then from negative 1 all the way to positive infinity, again, not including negative 1. Now, my range, though, there is absolutely no breaks in that graph. It goes up and down forever, so my range would be all real numbers. Okay, number 12, domain. My graph could be sandwiched from here to here. My whole graph runs from, that would be negative 4 up to 1. So there's your domain. All values from negative 4 up to 1. However, do you include negative 4? Answer is no, because that's an open circle. Do you include 1? The answer is yes, because it's a closed circle. So that's all you got to look for. My range would be how low and high does my graph go? So there would be my range is all values from negative 1, 2, 3, 4, 5, 6, negative 7 up to 2. So let's write that. All values from negative 7 up to 2. Now down here at negative 7, is that point right here part of your graph? The answer is yes. Is 2 part of your graph? Since they're both filled in circles, the answer to both those questions is yes. Now we're going to define function. We're going to talk about what do we mean by a function. A function is a special type of relation. So we're actually still talking about relations in which each element of the domain is paired with exactly one. Now this is important. Exactly one. It can't be more than one element of the range. So let's look at some of these examples and say, okay, which ones of these are functions, which ones are not. Each element of the domain, okay, each one of these x values can only be paired with a single y value. Negative 3 is paired with nothing but negative 4. Negative 1 is paired with nothing but negative 2. And you can continue on, and yes, this would be a function. However, look at number 14. You have a mapping here. And look at this right here is the problem. Negative 9 is paired with negative 2, but it's also paired with 5. Each element of the domain can be paired with only one element of the range, so no, this would not be a function. 15, would this be a function? Each element of the domain can be paired with only one element of the range. This is a function, yes. Now, what would make this not a function? If I threw in something like negative 7, 3 also, and I had this negative 7 paired with 2, and it's also paired with 3. So the easy way of remembering is if there's any time that there's repeat x's, if that x is paired with two different things, like it was here, negative 9 was repeated with two different values, that is not going to be a function. The way to test that with a graph is called the vertical line test. It says if a vertical line intercepts a relation at more than one point, then it's not a function. Now let's talk about why that would be true. If you have a graph and you have a point and above a point, that means a vertical line would hit both of those points. Well, what are those points? If this is like negative 3, 5, then this is like, well, if they line up, then this would have to be like negative 3 something else. So that would mean anytime they line up, they have the same x values. That's the reason the vertical line test says that if you can hit a more than one point with a vertical line, it's not going to be a function. So let's see on number 16, are these functions? If I can draw a vertical line and that vertical line hits more than one point, then it's not going to be a function because that means that x value would be a repeat. There's no points above points here, so therefore there's going to be no double hits with a vertical line. So yes, this is a function. 17, look how quick this is. Boom, I hit 2 points. No, that's not a function. This x value here is paired with this and this point, that both of those values. Here, 1 point, 1 point, 1 point. Now you do have an asymptote line that doesn't hit any points right here. and the rest of the time you're only hitting 1 point. So yes, that will be a function. So it's really quick and easy to see if something's a function if you have the graph.